Okay, this is video 2 for section 7.3, and for this video we're going to look at step 4 of this worksheet. So for step 4, the question we want to answer is this difference that we see? So we see a difference of the two means, but is it meaningful? Is it statistically significant? That's the thing we want to answer. And this section wants to teach us about the theory-based approach for determining this question. And we also want to connect simulation and theory-based approach. The theory-based approach is really a mathematical shortcut to not have to do simulation, because there's a pattern of the simulation that we can anticipate most of the time. Okay, so in order to do that, we're going to first start off with the simulation stuff and see how that relates to the theory. Okay, so we need to go to our shuffle options and click there. And I'm going to scoot over. And then we're told to do 1000. And then we're going to shuffle responses. Okay, now it might take some time because it's a big data set, so shuffling it 1,000 times is a lot. And if your browser happens to crash, just reload and do everything again and just make a smaller number than 1,000 to see if you can make it so your browser doesn't crash. All right, so here we have this stuff right here is the most recent shuffle, and then this is the histogram of all the shuffles. Okay, so record your estimated p-value. Well, you gotta, put that number there and count it. I'm not going to do it for you. Okay, and then fill in the blanks of the sentence to complete the interpretation of the p-value. The p-value of, this is where your number, is a probability observing. Now that blank is kind of short, but really you might need to fill in a whole part of a sentence. The probability of observing something, assuming something. So those last two blanks are actually much longer than they look. All right, so make sure you fill in everything there. Okay, so number 9. Is the difference in means, if the difference in means was larger, more different than 0, how would this impact the size of the p-value? This is the simplest one to answer because you could just make up a different number than this that's farther away from 0, plug it in and look. But you could also, hopefully you don't even have to do that. Hopefully you remember that if the difference is bigger, then the p-value will be different in a certain way, and you can put that down there. This is a review question. Okay, number 10. How would increasing the sample size, all else remaining the same, change the p-value and why? Okay, this should also be a review question from a couple sections ago, and some key terms for your answer would be variability of the null distribution. So, how does increasing the sample size change the variability of the null distribution? And similarly, how does changing the standard deviation of the original data affect the variability of the null distribution? That'll be for number 11. So for 10 and 11, a good thing to mention is the variability of the null distribution for explaining why. Okay, move over here so that I can see all the words. All right, now for number 12, on the left side of the applet, below the sample data window, use the statistic pull-down menu to select the t-statistic. Okay, so you can actually select it up there or down here. So I'm going to select t-statistic. I'll do the normal one. Okay, so then record the value of the t-statistic that is computed for your data. Write a one-sentence interpretation of this value. Okay, so I'm showing you mine right there, but what does it mean? What does the t-statistic mean? So do you remember how to compute it? The t-statistic is the just like what we talked about in the reading. The t-statistic is going to be sorry for my bad handwriting because I'm writing upright. x1 minus x2 minus 0, but I'll leave that out, over the square root of standard deviation squared over plus standard deviation of the other one squared over n. Okay, so, and then you could think of this as being the standard error. This should be the standard deviation of the null distribution. Otherwise known as the standard error, right? So if you're taking your difference and you're dividing by the standard error, then you are kind of measuring how many standard errors different are you, okay? That's my hint for that one. Okay, now for 13, in light of the value of the standardized statistic, should you expect the p-value to be large or small? How are you deciding? Okay, go back to that table from a while back of standardized statistics being between like -1.5 and 1.5 and -2 and 2 and -3 and 3, and use that to refer to that. The histogram on the far right now displays the null distribution of simulated t-statistics. Describe the behavior of this distribution. Okay, so behavior, you're looking for shape, where is it centered, and then yeah, that's the main idea. So shape, where is it centered, and then like a number that tells you how stretched out it is. Okay. Below the null distribution, check the box overlay t-distribution. So you it's not going to work for me because you actually have to put in a number before you do that. Well, actually it does work. Okay, sorry. Just sometimes a little slow. Okay, then if you have a number in here, it will also calculate the p-value using the theory-based approach down here. So enter the observed value of the t-statistic in the count sample box and press count. Remember to use the pull-down menu to specify what directions you want to consider. You might want to do beyond if that matches your hypothesis. And then how does the p-value from the t-distribution compare to the simulation-based p-value? Okay, so hopefully they're fairly similar. And that's because our validity conditions should be met here. The validity conditions required for this theory-based approach, a two-sample t-test, to be valid are shown in the box. Okay. So the quantitative variable should have a symmetric distribution in both groups, or should have at least 20 observations in each group, and the sample distribution should not be strongly skewed. Okay, so so in this case, do the validity conditions appear to be satisfied for this data? Justify your answer. So you can use two things in your answer, okay? You should be matching up whether our data matches this, but since our data matches the t-distribution really well, your answer should probably be yes. So how does our data match those validity conditions? Okay, that's the end of this video. We'll do steps 5 and 6 in the next video.